All right, we learned how to create NumPy arrays. Now let us perform some operations on them. Uh, let's start from again. Import NumPy as NP. Okay, we imported NumPy, and now let us create an array. Let's make a NumPy array. Let's do it manually, simply 1, 2, and then 3, 4, and the type would be float. So A is this matrix 1, 2, 3, 4, matrix 2 by 2, and let us create B as NumPy ones like A, right? So B would be this matrix 2 by 2. All right, let's do some math on them. We can simply add A and B, and each element here would be the sum of the corresponding elements in those arrays. We can do A times B, and again, well, it's an element-wise operation with a very easily predictable result. A divided by B, we can use, well, that's again not going to make much because it's we're dividing by 1. We can do, to illustrate it, let's C equals B multiplied 2. So C would be now, well, although we do this operation, we basically do it with a scalar, but it is performed element-wise, so each element becomes twice greater. So now if I want to do A divided by B, I would get on the second, A divided by C. This is what I was trying to do. So I would get these halves and 1 1/2 and so on. Same if I do, well, I can do the modulus operation, right? I can do a modulo C, right? So we get the remainder from our integer division, or whatever we do it element-wise. If we're dealing with matrices, we can also perform the matrix multiplication, but it won't be these A times B, right? The matrix multiplication is given by the either this operand, or you can do NumPy dot AB, right? Or you can do A dot B. So these all three of these options give you the result of matrix multiplication. Well, obviously, in addition to these simple operations, we can do all the math operations in our array. So once again, A is this array 1, 2, 3, 4. I can simply do NumPy sqrt of A, and that would give me a square root of each of the element, right? I can do NumPy log of A. That will give me the natural log. I can do NumPy exponent of A. Again, each element, well, it's e power to the element, right? This is e to power 1. Can take an absolute value. Won't change much, right? I can take a sign. And by the way, well, here it assumes that all that is not in degrees but in radians. I can do NumPy, I don't know, arc, tangents, hyperbolic. Okay. All right. Oh, well, it didn't really work. Why? Because well, you cannot take a hyperbolic arctangents from numbers like 1, 2, 3, 4. So it gives us what? It gives us inf for this first element and then for some other element. And these are then actually the numbers I wanted to talk about. So let me call it somehow. So let me call this matrix D would be this matrix, right? Look, it didn't give me an error, right? We have a warning, division by 0, right? But it's not really an error. And I want to say that you, of course, when doing different math, especially on large sets of data, you will have these issues like division by 0. So you will need to know how to work with infinites and these things nan, which stands for not a number. So infinite is obviously, well, it's if you do something like you divide 1 by 0, you will get a nan. Infinite. But if you do something like 0 divided by 0, that will give you a nan, not a number. It's not going to be infinity. And actually in NumPy, there is a way to check if something is infinity or something is not a number. So you can do NumPy is nan, and let's check for our matrix D, and it says, yeah, the 0 element, well, this 0, 0 element is false, it's not a nan, and the rest are nans. And you can also do NumPy is infinity, right, is inf of the same matrix. Yeah, and you can check this one is true and the rest is false. You can also check NumPy is finite of this, and it's going to be false for all of them because none of these, although nan and inf are different, but none of them is just a normal finite number. And by the way, if you want to introduce it manually, you can just do NumPy inf and NumPy nan to have these numbers. So the next thing I wanted to discuss, of course, is to deal with shapes and indexes of arrays. So let's say, well, I have an array C, which is, let me set it up manually, NumPy array, and let it be the following. It would be 0, 1, then 2, 3, and then 4, 5. Okay, and I want to keep it integer, so oops, that should be comma. So this will be this array, which is obviously, you can see it's a 2 by 3 matrix, and the way to get this is the method shape. So C shape will return you the shape of the NumPy array or matrix. Or if you had just one-dimensional array, that would be one number. So another thing, you can get the number of dimensions. This is a different thing. So this one, it's a two-dimensional array, right? It's a matrix 2 by 3, but overall the number of dimensions is 2, so ndim gives you 2. Also, you can get the size. The size will give you the total number of elements in your NumPy array, and also you can get type of your elements, which, oops, it should be not just type, it should be dtype, which will be dtype integer 64, the long integer type. And finally, you can actually do length of a NumPy array, which will give you 3, because that would be the length of the first axis of your array. So, but better one when you deal with NumPy arrays is to get its shape, to know exactly what how it is shaped. If you want to access different elements in the array, let's say you want to get, let's start from a simpler array. So a NumPy, let me make a range 4. Okay. So and if I want to get a 0, well, that will give me a 0 element. From my matrix C, if I do C 0, it will give me this 0 element, which is this this array by itself. So it will be this array 0, 1. If I do I'll see 0, 0, then I will get the element with indexes 0, 0. So this element of the matrix. So C1, 1, as you can guess, will give me this element. Okay. Well, then, if I want to get an entire slice of array, let's say the first column, right? I can do the following. That would give me the first column of these array, and well, slicing works similar way as with lists, and we'll talk more about slicing because it's pretty, I would say it's pretty complicated for NumPy arrays. But let me just give you another example. This is that will give me this slice of my two-dimensional array. Also, the array can be changed. So if I take my A and say A1 equals 100, my A becomes different, right? The element with the index 1 becomes 100. I can do the same with C, and if I do C1 equals 100, I will overwrite the entire slice with 100s, and I can actually fill the whole array with a certain value if I use cfill, and let's say -10. So now I overwritten all the elements in my C with -10. All right.